Hello class, welcome to our second lesson dealing with the surface area of prisms. We're going to continue talking about the nets and how to find the surface area of different prisms. So let's go and get started with, again, a review of dealing with percentages. These three questions here, you may just want to write them down. I've given you the answers to these three questions. You need to be comfortable about how to find things with percentages, whether it's the part, the percent, or the whole. So my recommendation is that you write those three questions down and make sure you understand how to do those, because they may show up on a test situation or any homework check situation as we continue to move forward in the semester. So remember, you can do the equation, x equals, for this first example. If you're going to do that, you got to make percents into decimals. If you do the proportion, remember it's part over whole equals percent over 100. And then the percent questions you can also do either way. So please make sure that you're looking at those. Make sure you understand how to do those three questions as we move forward in the semester. Basically, what we're going to look at today is just different types of prisms and how to find their surface area and lateral areas. So notice here I have a rectangular prism. It's important to realize that the 3 by 5, see how it says 3 inches by 5 inches is the bottom, and the top, and it's kind of in red. Those are the bases for this rectangular prism in these scenarios. Drawing the net, I kind of just think of taking the front and then unfolding it. Okay, so this is 6 by 3. This is the front here. And then these next ones are 5 by 6. That's why these two left and right of that are 5 by 6. And then another one for the extra 6 by 3. And then the two top flaps. Now notice my picture's not kind of drawn to scale. Honestly, right now, that's probably the lower on the list of things that are worrisome. We just need to be able to get at least a picture set up so that we can get the net drawn out. And then the surface area is 2 length width plus 2, so 2 times 6 times 3 plus 2 times 6 times 5 plus 2 times 3 times 5. And I get 126 square inches. Remember, you could not have a top or bottom to some of these questions, so you may only have one of them. Don't memorize formulas every time. Use the application of the net versus the sides in order to find the areas. Some students also just find the area of the 3 rectangles, so they do 6 times 3, 6 times 5, and 3 times 5. Find that answer and then double it at the very end. That would be another option for that situation. You need to make sure you show your work on a question like this so that we can see kind of where everything's set up. The other nice thing about your work here is if you're asked to find the lateral area, remember that's everything but the bases. So the base here is the top and bottom rectangle, which is the 3 by 5s. So these two 3 by 5s are just gone. And as long as you have work shown, really what you could do is kind of like what I've done and say, oh, well, these two here, this is the lateral surface or the lateral area of this object. And that would be 96 square inches, which basically just gets rid of the 2 times 3 times 5, which is 30, and gets rid of that group in order to find the lateral surface or the lateral area versus the surface area. You'll be asked about both things. We're looking for nets. Remember, your book doesn't always talk about nets, but you need to draw them. We're looking for the surface area, and then also find the lateral area, which is those areas of the pieces around when you add them all together. The next one is a triangular prism. Now for a triangular prism, my suggestion would be draw the 3 rectangles first. So this one here is 3 by 6. This one's 4 by 6 on the right side, then blue. And the back one, which you can't see, is 5 by 6. So I got a 5 by 6, a 3 by 6, and a 4 by 6. The key is that the two triangles on the bases should look identical if you fold them up towards each other. So some of you that are more visual learners, this is very easy to do. Notice here I have a 3 and a 4 that make a right angle. So I just use that as my reference. I need the 4 to be over here because 4 is also to the right on this rectangle, and they would fold together and match up perfectly, as opposed to the hypotenuse, or the long side of the triangle, should match up to this rectangle on the left side. When I find the surface area of this, there's 2 triangles, so I would do 3 times 4 divided by 2 times 2 of them. So 3 times 4 divided by 2 times 2 of them. And you could do 6 times 5, 6 times 5, 6 times 3, and 6 times 4, and add those together for 3 rectangles. Another option is that really that middle rectangle is just one big rectangle that has 2 folds in it. So I chose to just add up the perimeter of this object by taking 3 plus 5 plus 4 and add all those together, and that will be multiplied by 6 as one big rectangle. You can do either option. Just make sure that you show your work in order to get a final answer of that. And the surface area would be 84 square meters. The lateral area, no matter how the triangular prism looks, is always the area of the rectangles without the 2 triangles. Always. And so that would just be the 6 times 5 plus 3 plus 4, which would be 72. Or get rid of the two triangles. Another option is you find the answer and then just say, oh, subtract the 12 out from the two triangles, and that would also get you your answer of 72 square meters. The next question is my favorite. It's a cube or something like a die for rolling, for example. This is the easiest one to find the surface area of because it's just 6 squares. Okay, the net's easy to draw. It's just 4 squares in a row and then 2 squares top and bottom. So really it's just 12 times 12, and then there's 6 of them. So that's how I found the surface area, which would be 6 times 12 times 12, and that's 864. The question is which one's the base. It doesn't really matter. They're all the same. So instead of doing 6 of them, to find the lateral area, you would just do 4 of them. And that would be like the 4 kind of around the edge without the top and bottom. Okay, so it would just be 4 times 12, which would be 576 square meters to find the lateral area for the cube in this case, which is just a special version of a rectangular prism. So you could do the same idea as the rectangular prism. It might save a little bit of time by just doing 6 times the area of one of the sides, though, for something like a cube. One thing that's important about surface area to understand is things like boxes that are sent in the mail and even boxes for transportation and things of that nature typically do not look like a cube. So I'm thinking like cereal boxes, for example. I don't think I've ever seen a cereal box that was a cube. They're much more rectangular prisms, and there's a very easy reason to explain why. Okay, the question is which prism has a greater surface area? So I could go through the prisms really easy. Take 9 times 9, the area of one of the faces, and then times 6 because there's 6 of them, and I get 486. If I do the same thing on this second one, I do 2 of the length width, 2 of the length times height, 2 of the width times height, and I get that answer, and it's 430. Notice here that the dimensions, if I take 9 plus 9 plus 9, that's 27. If I take 5 plus 15 plus 7, I also get 27. So just because the 3 side lengths add up to be the same number does not mean they have the same surface area. The cube has a higher surface area than this rectangular prism does. Okay, and the volumes will probably be a little bit different as well. If we're thinking about just a box, though, in terms of surface area, that's important to a company because that's how much cardboard would be needed to make the object. Okay, so when we're looking at rectangular prisms, the reason that sometimes they're longer and skinnier, like a cereal box, for example, rather than a cube, even though I think it'd be cool to have a cube cereal box, 2 things. One is, it'd be hard to pour a cube cereal box. It's much easier to be able to hold the cereal box in one hand and be able to pour. Okay, that might be one reason why they went with the skinnier box. The other reason is strictly a financial reason, maybe dealing with surface area. The long rectangular box has a smaller surface area. This would be similar to the idea of the envelope question in the last chapter. The smaller surface area means it's going to cost a little bit less to make the box. And that will save the company a lot of money if they're producing millions and millions like some of these cereal box companies do. So the prism that has a greater surface area is the cube, which is typically the case compared to a rectangular prism with similar dimensions. And the reason is because these areas are the kind of these perfect versions, and we're not shrinking anything down to mold it into something that has a smaller surface area. Also notice, even an easy question like the cube, I'm showing my setup and equals the answer. For surface area over here on the right, I'm showing all my setups equals the answer. Same idea would be true in these questions for your homework. Homework questions 10 through 15, make a note on your homework assignment. You need to draw the nets. Your teacher will be looking for that as we kind of move through this section. You need to be able to draw the nets on questions 10 through 15. And then 19 and 20, 25 and 26, you don't have to necessarily draw the nets, but they're kind of application-based questions a little bit more. You want to make sure you show the steps on all questions so your teacher can see what your process was. Draw the nets when told to, like on 10 through 15. Even though the book says that it's not necessary, I want you to be able to do that. So on 10 through 15, please try that out. And remember, for any prism, the 2 bases are the 2 pieces on the 2 ends, whether it's this way or this way, that are the same. So if it's a triangle-based prism, there's 2 triangles on the 2 ends. If it's an octagon-based prism, there's 2 octagons on the end, things of that nature. Also, there's no set formula. Don't expect to have a set formula in all of these prisms. The rectangular one has a formula you could use, but again, you don't want to be doing that all the time. You want to just understand area of the sides or the faces and then add all of those together. Have a good day, everyone.